Hello everyone, this is KP the Math G here. We're talking about separation of variables. We've been doing that, I want to say, we've had maybe one or two lessons on that. I think we've had two. But this time we're going to do a particular solution. This is the first lesson where we're looking for a particular solution. You're going to be given a differential equation, okay, and on the side you're going to have an IC. That's called an initial condition. Y at 0 equals 6. That is, y equals 6 when x equals 0. So don't get these mixed up. So in the first place, you need to remember this is not x, this is x here. So y at 0 equals 6, okay. This might be y at x. So in this case, x is 0, and then the y value is 6. Okay. Keep that in mind. Okay. Just keep that in mind. Alright, so let's do a little first of all, we need to separate the variables. One thing we can do, you have to learn strategies as you go. A few of the little nuances of these, trying to solve these problems. If I have something plus or minus something, and I want to just get that over there on the other side, okay, like that. All right, I'm going to do that. I'm going to add 6x to both sides, 6e to the x rather. So plus 6e to the x plus 6e to the x on both sides. This is going to be y dy over dx. This is 0, so this equals to 6e to the x. Now, to separate the variables successfully, I got my y dy. I just need that dx over here, and that's nice because dx is in the denominator. I can simply multiply both sides by dx. I can get rid of dx on the left side by multiplying, and notice this is really over 1 if you want to do it that way, and this divides out. So now I'm left with y dy is equal to 6e to the x dx. Okay. Now the variables are separated. I know they are because I have a y with a dy and a x with dx. Okay. Once we get that, we're ready. What are we ready to do next? Once we separate the variables. By the way, if you're dealing with the AP test, where you're probably most likely, I say most likely, watch you not get it this year, you get at least or at most one problem on separation of variables. Okay, I would say you will likely get it, but there again, as I say that, it may not appear. It usually does, though. Okay, on most exams it usually does. Alright, so learn how to separate the variables first. Okay, now once we separate the variables, you know what to do. We integrate. I'm going to move the 6 out of the way just a little bit. Okay, like that. And I'm going to integrate both sides. This is easy to integrate, isn't it? This is y squared over 2 equals 6. What's the antiderivative of e to the x? E to the x, isn't it? So 6e to the x plus c. Okay, does everybody see that? Now, oh yeah, by the way, this c is very important. If you do not tack on the c, you're not going to be able to do this from here on out. So at the very most, you're going to get 1 point if you can separate the variables, maybe a point if you integrate. I don't even know if they give you that. I'm not sure. But you're definitely not going to get it if you don't put the C down. Okay, that's part of the integration process here. Alright, that's called the constant of integration. Put it down there. Alright, now we want to find out what C is when y is 6 and x is 0. Alright, so we're going to substitute that in right up here. Alright, 6 squared over 2 is equal to 6 e. Now remember, this x is 0 plus c. 6 squared is 36. 36 over 2. Now do not do 6 over 2 is 3 and 3 squared is 9. Don't do that. Only the 6 is squared, not the 2. Alright, is equal, now e to the 0, what's that? It's 1. So 6 times 1 is 6 plus c. So now we've got 18 is equal to 6 plus c. Right? We're going to subtract 6 on both sides, and we get 12 is equal to c. Alright, c is 12. That means, to finish this problem, I'm going to erase my c. So easy for me, I can just erase it with my hand, right? With my fingers. There's my c right there. Remember, this was a c here, and in place of c, I put 12. That is my equation. Now, do you stop there? Well, I don't know the answer to that. You may have to ask your instructor or professor or whoever it is that teaches you calculus. Now, the AP students, you AP students, you can stop right here. I don't know. So once again, you might need to ask your teacher or instructor or professor, whoever it is who teaches you this. If you need to go a step further, and a lot of times, sometimes instructors or those who do workshops for us, for teachers, I'm a retired teacher now. I don't get a chance to go to the workshop, so I don't know all the nuances that go on now. I know most of them, but still, I'm out of the loop a little bit now. So, but now, they may say just stop here. If you need to go further, you can. Okay, so this is y squared over 2 is equal to 6 e to the x plus 12. You can probably multiply both sides by 2. Alright, and then this is going to be, now the 2's are going to divide out, and so you got y squared is equal to, multiply this side by 2, that's going to be 12 e to the x. 12 times 2 is 24. Well, do you take the square root of both sides? Maybe so. I don't know that for sure. So I'm just going to leave it like that. If you do take the square root, you're going to get a plus or minus here. And so sometimes you have to be careful with that, because some answers are not required to be negative. Okay. Alright, so anyway, that's how you do it. So what do? You had to separate the variables. Well, actually we added the 6e to the x to both sides, but in the process we separated the variables. We integrated, we added the plus c on the end. We plugged in the numbers, x is 0, y 6. And we found the not so general equation. It's not general anymore. It's a specific or a particular solution now. Okay? So that's what it means to have a particular solution. C is not just anything anymore. It's 12. That's why it's called a particular solution. A specific solution. Okay. Alright, that's problem. This is the first example here. Okay. Feel free now. I know you can't comment during the lesson, but after the lesson is over, after I process this lesson, feel free to comment on it. okay? And tell me what you think, okay? All right, I trust that I have explained this well enough for you to understand it. We're going to the next problem, okay? Here's the next one. Okay, dy over dx is equal to xy cosine y squared. Okay. I'm thinking that I should have wrote this as cosine x squared. That does not look correct. So let's make it an x here instead of a y. Otherwise, we're going to have trouble integrating this. Okay, so let me change that just a little bit. I'm trying to find the original marker. I have a bad habit of putting markers in my pocket. So we're going to make this x squared instead of y squared. Life gets a little easier when we do it that way, believe me. I tried this with y squared earlier and it was kind of difficult to work it out. So probably too difficult for the scope of this class. And so we just have to make it a little bit simpler here. Alright, let's go ahead and do this. I have an x and a cosine x squared here. I've got a dy over dx over here. So what we can do, what do we do? Yeah, that's right. We multiply both sides by, let me move this over just a little bit here. I'm going to move this, I'm going to multiply this both sides by dx. And remember, this can be written as dx over 1. Dx over 1. Okay, times dx. Squeeze it in there. Alright, so that's dx right there. Let me write it a little more plainer. Times dx. Oh, I'm squeezing that in. So, alright, there it is. The reason you want that, you want to get that, you don't want dx in your denominator. Okay, you want to get rid of that. And no matter what happens, let's rewrite our problem. Now we're down to dy. I'm just trying to show you what we got here. xy cosine of x squared. Okay, everything looks pretty good. We're almost there. It would be nice if this y were with the dy here. I've got x. Oh, I got my dx here. Woo, almost forgot. I just multiplied both sides by dx. Okay, there it is. Okay. You know, I'm still KP the Math G. Okay, and sometimes KP the Math G misses something, but I still caught it, so it's all good, isn't it? X's together with dx, that's good. Let's get this y out of here. This is all times, so I'm going to divide both sides by y. My goodness, that's familiar to me, isn't it to you? dy over y. dy over y is going to be, now this is gone here. Alright, x cosine x squared dx. Okay, right there. Alright. Well, we know what to do next. We have to integrate, don't we? Alright, let me get another color. I'm going to integrate both sides. Anybody know what this left side is? Yeah, that's right. It is ln y. Okay, we'll put that in absolute value bars for now. I put my plus c over here where the x side is. That's okay to do that. You can have a plus a c1 and a c2, but you'll wind up having c2 minus c1. Just make it equal to c. Just put a c on this side. Yikes. How to integrate that? Yeah, okay. Oh, wait a minute. I noticed this is a square and this is an x to the 1. I can do that by U substitution, can I? U substitution. So in other words, I'm saying let U be equal to x squared. Then du is equal to 2x dx. The derivative of x is dx. And I've got x dx, don't I? Right here. But I got 2x dx here, don't I? So I can simply multiply by 1/2. 1/2 here and 1/2 here. So 1/2 du, 1/2, that looks better if I write it neatly, is equal to, now notice these twos divide out, x dx, I have that here. Alright, I have u here. So let's see, I've got this right here. So I've got, okay, let's see. This is cosine. I'll let u be x squared. U. And this is du. Oh, wait a minute. Almost forgot my integration symbol. Now that's sad when KP the math G, of all people, leaves out the integration symbol. Alright, let's put this 1/2. I forgot that in one of my videos before. I had a 1/3 and left it out. I'm not leaving it out this time. Now 1/2 cosine of u du. There it is. Whew. Okay. Now, I've already integrated this left side. That's just ln y. I have to integrate this. Well, what's the antiderivative of cosine? Derivative of cosine is negative sine, but the antiderivative of cosine is sine, simply because the derivative of sine is cosine. So here we go. This side. Ooh, we're running out of space, aren't we? So we have ln y is equal to 1/2. Alright, sine u, okay, plus c. And maybe I should put plus c in here. Doesn't matter, I think it'd be alright. We could do that. You know what I want to do before I start putting e to the ln and getting y by itself? I mainly just want to find out what c is, don't you? I get down to this point right here, I can, oh yeah, by the way, u is x squared, isn't it? So, okay, so in place of u, I'm going to put x squared. Let's do that first. First things first. So let's make this x squared, okay. Alright, so there it is right there. That's it. But now let's substitute now. Y is 1 when x is 0. Alright, so y is 1. ln 1, and since 1 is positive, we do not need the absolute value bars. I should have noticed that from the start, that 1 is not a negative number. Okay, I should have thought about that, but I didn't, but it's okay. 1/2 sine now 0 squared plus c. Well, obviously, what is 0 squared? It is 0, isn't it? And sine of 0, okay. Well, I'm going to need to flip this over. Sine of 0. Well, maybe not. I'm just going to draw this up here real small. I know it's kind of small, but here's x and here's y. So sine of 0, sine does this, doesn't it? So here's 0, and sine of 0 is 0, isn't it? So sine of 0 squared is the same as sine of 0, which is just 0. So I have a 1/2 sine 0. And I guess maybe, I don't know. I don't believe I need to put that plus c inside there. I can put it outside here. Okay, do that. Sorry, everyone. It needs to be on the outside like this. Okay, plus c. Okay. The 1/2 belongs to this. Okay, so plus c. Alright, is equal, ln of 1. ln of 1 is 0. And you can punch that in on your calculator. Let's see what we got here. And let's see. Sine of 0 is just 0. Okay. This is just 1/2 times 0 plus c. It appears to me that, well, yeah, that's right. Okay, so this is 1/2 times 0, which is 0. And I don't guess it mattered whether this was out or inside the bracket or not, because all this is 0 anyway. So let's see what we have here. Let's see, I'm going to need some more room. Okay. I don't want to erase anything though, but I'm going to go ahead and erase this up here. Okay. Bear with me, guys and girls. I tell you, I apologize for sometimes the lack of convenience here. I'm going to use a different color up here at the top. Let's get black this time, I guess. Okay, so what I have here is 0 is equal to 1/2 times 0 plus c. And then this is 0 is equal to 0 plus c, which means that c is 0. Well, that's all we did. We did all that to get c equals 0, didn't we? Okay, oops. Okay, so let's see. Here's our equation here. So really and truly, when we plug 0 in for this, we get 0 right here. Okay, and basically that is what I find here. So lny is equal to sine 1/2 sine x squared. Okay, so that's that. Okay, it wouldn't have mattered. Okay, had we left this in here like this, we still would have gotten 0 anyway, because if we had distributed the 1/2, okay, had we just left it like this, we're still going to get 0 anyway, because 1/2 sine 0 is 0, 1/2 c is 0, and we would have distributed the 1/2. We would have had 1/2 c, so 0 is equal to 1/2 c, but still c is equal to 0. Either way, it's 0. Okay, so it didn't matter if you had the c included in the parentheses with the 1/2 on the outside, or just left it out here. I think either way it's going to be all right. Okay. Okay. Well, we got all this work just to get 0 sometimes, and sometimes that happens. All right, so let's see what we have here. I want to erase a little more. Okay. So really what we have here is lny, which y is positive, we don't need the absolute value bar, is equal to 1/2 sine x, well, let's put it in parentheses, x squared. Okay, like that. Plus 0, okay, we don't need that anymore. If we wanted to do this, I could make this over 2 right here if I wanted to. Make this sine over 2 like this, and then introduce e to both sides if I wanted to get y by itself. So now y is equal to e, and I need to raise that up to the sine x squared all over 2, like that, and that's all raised up as an exponent. Okay, alright, there it is. Okay, that's pretty much it. I did want to introduce something that had a trig function in it, okay, and get back familiar with finding the antiderivatives of cosine or sine or whatever we were doing here. In this case it was cosine, okay, and then just learning how to write this if you want to solve for y, okay, and that's pretty much what we have here. Okay, once again, this is KP the Math G. I hope that this has helped you understand what we were doing. To recap, we had a differential equation, we had an initial condition. That's what you're going to be left with. You're going to start with that, then you're going to separate the variables. Once you separate the variables, you integrate. This one had to be by u substitution, okay, and then once we did that, then we had to plug in, do not get down to this, start right here, plug in the x and the y values right here, and that makes life a little simpler. We found that c was 0. Alright, then e ln y, since this was just ln y here, e ln y is just y, and then e raised to the sine x squared over 2 right here. Remember, this is all an exponent right here, okay? Alright, alright, that does it right there. Alright, this is KP the Math G. Don't forget to hit the subscribe button if you will, and if you want to make a comment on anything that I have done here, please do so. If you see something I could have done a little better or easier, please show it to me, but you need to be right when you show it to me, okay? Please do that. I invite that, really, because I need to, you know, I can always improve, I can always do better, so I can teach you better how to do things. Okay, so I'm always learning and improving and striving to get better and better. And that's what we should do really with our lives in general anyway. Strive to get better and better, to be better people. Alright. Anyway, also, if you see something, you know, you comment, say, hey, great job, KP. I'll take compliments as well. I'm not here to brag or be bragged upon. I'm here to try to help you understand this a little bit better than you did before. Okay, this is KP the Math G signing off. Have a great day.